So my name's Henry Samuel, and I'm your moderator today. Delighted to be with you. Hope you're ready for action. So this panel discussion will focus on excellence and performance for competitive nuclear energy. That is the subject of the day, and I'm delighted to have a panel of distinguished speakers. So let's give them a warm welcome here. First of all, we have the CEO of Framatome, Bernard Fontana. Let's give him a round of applause. We have the Executive Vice President, Chief Operating Officer of Exelon Generation, Michael Pacillio. We have Group Senior Executive Vice President, Nuclear and Thermal at EDF, Dominique Minière. And we have the Vice President of CNNC China, Zhonghuan Engineering Corp, who is in charge of Project Procurement and Operations Service, Mr. Wang Yongge. So before we get down to the business of the panel discussion and the theme of the day, just a very quick look at each of your activities, just in a few words. So let's start with Mike.
Thank you very much. Can you hear me okay?
Stick it on the chin, Mike.
Can you hear me okay? I am the Executive Vice President, that was stated, Chief Operating Officer of all commercial grade generation for Exelon. So I was the chief nuke prior to that. Kind of grew up in the nuclear plants. Now I oversee our 21 gigawatts of nuclear and about 12 gigawatts of natural gas, hydro, wind, solar, have a biomass plant, a digester plant, kind of all different ways to make electricity. So that's under me.
Thank you very much. Indeed, Mike. Dominique.
So I am Dominique Minière. I am the Group Senior Executive for nuclear power plant and thermal power plant in France for EDF, in charge of both nuclear power plants. It means 58 reactors, 58 nuclear reactors. Also some thermal plants. All the engineering which is supporting us for the upgrading of our fleet. It means about 30,000 people I am in charge of managing. So before I was CNO of the fleet, and before to be CNO, I was Deputy CEO in charge of all the technical issues and nuclear safety issues. And just before, I was a site VP of nuclear power plant in France. And I spent also 4 years in China to support Diabe operation at the beginning.
Thank you very much indeed, Dominique. And Mr. Wang Yongge.
我来自中科集团。中科集团主要从事核电、核燃料循环和核技术应用等的科研开发、建造和运营，以及对外合作和进出口业务，是中国在运核电和在建核电的主要投资方，也是中国大陆所有的56台核电机组的建设方。中核集团有30多年的工程建设经验，进口和出口了多座核反应堆及核设施，积累了雄厚的技术实力和丰富的管理经验。我本人来自中核集团下的中国中原对外工程有限公司。中原公司是中核集团的海外业务平台，是中国唯一的核工业全产业链的出口商，也是中国第一个最大的海外核工程的建造商。
I'm from China National Nuclear Corporation, and this is a corporation that mainly engages in the research and development of nuclear power, nuclear fuel cycle, nuclear technology application, nuclear environmental engineering, and etc. It is also involved in MPP construction and operation, international economics cooperation, and import and export business. It is the main investor of China's nuclear power plants, both in operation and under construction, and undertakes the construction of all 56 MPP units at home and 6 units abroad. CNNC has over 30 years of experience in nuclear engineering and construction, and has exported many reactors and nuclear facilities. It has developed advanced technologies and accumulated abundant management experience. I personally working in China Zhongyuan Engineering Corporation of CNNC. This is the overseas business platform of CNNC and the only Chinese company that exports technology of the whole nuclear industrial chain. It is also the first and largest Chinese contractor of overseas nuclear projects.
Thank you very much indeed, Mr. Yong. So now we have an overview. Apart from, we haven't mentioned, of course, Framatome. So, Mr. Fontana.
Thank you. So Framatome were 14,000 employees, mostly experts, engineers, technicians in 20 countries, and we share a vision to be high-performing people and technologies for safe and competitive nuclear plants worldwide. Roughly our sales 3.3 billion, backlog of 14 billion euros, and our expertise is the nuclear reactor, the NSSS, nuclear steam supply system, and based on this expertise, we have activities in maintenance of installed base. We produce nuclear fuel, control command systems, heavy equipments, and contribute to large projects. And we want to do all this with values, safety first, but also future, and we believe in nuclear, performance, integrity, and passion.
Thank you very much. So we're going to get down now to talking about performance and competitiveness. Just a quick reminder that you can ask your questions. In fact, I'd really invite you to ask questions during, that we will answer at the end. All you have to do is send a text to this number, 336-446-01500, or go to the address there. So ask your questions and then we will answer them at the end. So let's get down now to the panel itself. So faced with an ever-increasing demand for, as you know, low-carbon, safe energy, utilities find themselves up against a twofold challenge, and that is operating the existing plants while optimizing maintenance and, of course, commissioning new builds. And it's the energy market itself is becoming increasingly competitive. So to respond to this, the nuclear sector is reinventing itself, and it's focusing all the energy on operational excellence and performance, and by maintaining, enhancing key skills and new tools. So that's what we're going to talk about now. So Bernard, I'll start with you. Quite simply, what programs have you implemented to improve operational excellence and performance?
Yeah, and as a character in this sector, we are committed to this approach with major utilities all around the world. First, the cornerstone for us is safety. Always start with this, nuclear safety, OHS, and it's needed, and when you can do it, you have the proper technologies, the proper managerial precision to deploy your programs. We rely on three pillars. The first one, I would call it the skills approach, knowledge transfer, and capitalization. We're a technology company. We want to continue to strengthen our skills, our expertise, hire people, transfer the knowledge, and make sure we keep this knowledge and that the people will stay in the company to carry this knowledge. So for us, it means not only hiring, developing the people, but it means also knowledge management. And we made a benchmark on how the best do in the world, and we really want to be a reference in knowledge management. We learn. It means also return on experience that also fits this knowledge management. The second pillar for us is execution and performance in execution. Here we have the new build sector. Clearly, to improve our performance, we systematically deploy system engineering with the proper tool, the proper processes, the return on experience again. And as for the operations, it's about project management, it's about methodology, operational excellence methodology you can find in industry, always requiring precision. There is something specific, I think, in the nuclear industry. You have so many reasons in the environment we're working to stop, to wait for an approval, to wait for something. So for me, it's important to have the proper organization with the skilled people able to decide at the right level. And to promote this, for example, in the company, we launch a program with suggestions by our employees. They can fix themselves. And the challenge this year is to have 30,000 of them, and we're on track to make it happen. And I think this is a call to the skill and the strength of the employees. The third pillar for us is to understand that we cannot do it alone. We are part of a supply chain with the nuclear operator, but also with our partners. And we must make sure that we put them, our contractors, we put them in a situation to also secure their knowledge, secure their capability, make sure their work get trained to deliver performance, to be associated to a collective performance, and this can also be in the contracts with them, because ultimately the value we create for our customer is based on our capability and on performance in execution. So that's in a nutshell where we are, and of course, like everybody, we make sure we are competitive and we are very cautious on our G&A, the G&A of the company. We want to use our resource for technology, for industrial muscles.
Thank you very much indeed, Bernard. So let's move on to the rest of the panel now. The question, Mike, again, I pose to you is, what are the challenges and the key success factors, in your opinion, for competitive nuclear energy? I know it's an obsession with you.
Well, in the United States, it's tough sledding today for nuclear operators. We're battling in the merchant market. We're the largest merchant generator in the United States. This three-headed monster, which I'll describe to you as natural gas, the abundance of natural gas, and the technological improvements to leverage that abundant natural gas into electrical energy. I'll talk a little bit more about that. Subsidized renewables is second, and then energy conservation, energy efficiency is the third. So back to natural gas. In the States today, you'll find gas at the hubs running between, those that follow the market, between $2.5 and $3 a million BTUs. So just very, very cheap, very abundant natural gas with the onset of fracking. That sets the electrical market in the merchant generation world in the States. So we have to compete against that. In addition to that, renewables are subsidized. So wind and solar are subsidized in the United States through a number of different means, which means that our wind generation fleet in the States can actually be dispatched at an energy price of 0 and still make money. That is hard, as you can imagine, to compete against. We're good, we're just not that good. So we need a little bit of margin. And then third, energy conservation, energy efficiency. All the major metropolitan areas for Exelon, we are the hometown utility for Chicago, Philadelphia, Baltimore, Washington, D.C., the state of Delaware, and Atlantic City. In all those very large metropolitan areas, the load growth is flat to negative in each one based on energy conservation, energy efficiency initiatives. So it just makes it very difficult. So with that in mind, regulatory policy is game one for us. We need to have our nuclear plants valued for all the societal benefits that they bring, such as carbon abatement, clean air. We look at it as an imperative, from a national security imperative, that nuclear energy, we stay relevant in the United States and it remains within the mix. We have 2 years of fuel on most of our plants on site from a fuel redundancy perspective, which also gives us an advantage. So the current administration is very open and listening and very supportive. Currently, our Secretary of Energy, Mr. Perry, and he is interested in finding a way on how nuclear can be subsidized, like wind, for the societal benefits that it brings, just to get us on a level playing field so that we can compete. In the meantime, safety, operational excellence is always job one for us. And if we can't operate our nuclear plants at the excellent level, then we won't operate them.
So that brings me to my next question. What have you done or can you do to improve operational excellence, given all of the constraints that you've just mentioned? And how is Framatome supporting you in this?
Well, first of all, we shamelessly steal from all of our colleagues in the nuclear way, as you all know. It's the way we remain excellent. And my colleagues from France, my colleagues next door in the States, there are no secrets in terms of initiatives that directly affect nuclear safety. We share openly. In fact, Dominic sits on a board that I sit in. We jointly own 5 nuclear power plants in the United States. So we share ideas about how we make our plants more safe, more reliable. At Exelon, we work under what we call a management model. So all of our programs and all of our policies are standardized in the United States. So whether you go to a plant that I have, one of the 11 reactors in Illinois, one of the 5 in Pennsylvania, or one of the 2 in Maryland, or the upstate New York plants, you'll find the same implementing processes for those programs and policies at every one of our plants. Framatome is a very valued alliance partner to us. They are integrated into the way that we operate our plants, in particular, do our refueling outages. We average about 14 refueling outages a year with our fleet. We average about 21.7 days is what our refueling outage duration is. So as you can imagine, planning, having the right people that understand how to work within those processes, that deliver what they say they're going to deliver when it's supposed to be delivered, is vitally important to us. And Framatome does that in many different ways.
Thank you very much, Mike. So on to Dominique. Again, I'll ask you the first question, which is what are the challenges and the key success factors for you for competitive energy, nuclear energy? Take the other one because it doesn't seem to be working.
Thank you, Mike. So EDF is a leading nuclear operating worldwide with a standardized nuclear fleet of the 58 reactors, as I said before. But we are also involved, in fact, in China, in Taishan power plant. So we have 30% of the share of Taishan nuclear power plant. We are also involved in Great Britain because we are managing EDF Energy. As said by Mike also, we are involved also in US because we are together at the same board of directors of CNG, operating five reactors in US. So it gives us a broad view of how to operate nuclear, and mainly as with the first point, which is safety, nuclear safety. Without nuclear safety, you cannot operate any reactors worldwide. What is sure is that in France, we have an asset for our country, an asset of 58 reactors, which is very important. One of the most autonomous nuclear industry in the world. We have our wish and our will and our aim is really to fight climate change, really, and with a single goal to become the benchmark leader of low carbon energy worldwide. That's our purpose. How to by relying on our extremely low carbon electricity mix. As a matter of fact, we have one of the lowest and probably the lowest carbon footprint in Europe now as an electricity producer, because we are relying on nuclear and hydro mainly. And even if it's a proportion, I think it's the same in US and a lot of countries, the proportion of electricity in the energy mix is only 25%. So for us, the main point is how to increase the percentage of electricity in the energy mix, because it's probably the best things we could do for environment in the coming years. So the most cost-efficient solution to prepare the energy mix is really to continue operating our existing nuclear fleet after 40 years, like it is done like we are doing with our US colleagues. It's very clear. It's a fundamental challenge to keep over the long term, a base load nuclear output in efficiently large, quarterly, and carbon-free. Carbon-free because I would like to remind everyone that nuclear power plants are not emitting any CO2. It could be strange to say that, but you have to know that 50% of the population in France thinks that nuclear is emitting CO2 because of the chimney with chimney and so on and so on. So just to rely on, to insist on this point, we are not emitting any CO2 in nuclear. You have to say that every time you can say that. It seem very simple, but a lot of people don't know that. So it's basic things. So our fleet, moreover, is capable of responding of climate events, and our reactors are flexible enough from 20% to 100% of power to adjust to the variable nature of renewable energy. We would like to increase renewable energy in our portfolio, but you know that renewable energy is variable depending on the weather. And the best pillar and the best key pillar of the energy transition in France to support the increase of renewables is obviously the existing fleet, because we are able to complement renewables, the increase of renewables in France, when we will increase this point. Some industrial requirements are essential to operate the power plant over the long term, operate the fleet in an efficient and irreproachable way. Safety first, as we said. I think that's a key point for us. A second point also, to continue to enhance the safety level by ensuring one thing which is very essential, we have seen after Chernobyl, we have seen also after Fukushima, is that whatever, we could have an accident. Nobody can say we could not have an accident. But whatever the accident, there should be any consequence, long-term consequences outside the reactors. And this is possible to enhance that, to enhance the safety level to this kind of safety level. That's what we have done, and we will go on doing. And moreover, we have also to renew and retain our internal expertise in engineering and operation with a committed and empowered nuclear staff. Just to give you a figure, we have renewed in the last 7 years 40% of our staff. 40% have get retired, and they have been replaced. And despite this replacement, the safety level of our fleet has increased. So that's very important to go in this way. It's a key point for us. And moreover, we have to conduct a large-scale in-house R&D program in cooperation with external players. And to continue operating our reactors and generating a substantial output of carbon-free electricity, we have launched a major industrial program in 2014, the fleet-wide refurbishment project named Grand Carénage. It's 40 billion euros investment on the 11 years, I have noticed. 40 billion investment to do what? But to increase and to enhance the safety level during first 10 years outage, mainly. To take into account the post-Fukushima conclusion and improvement we have to do, and also to replace a large number of components, big components that we have replaced, you have to replace when you are going to 30 years of operation, as our US colleagues have already done, because a lot of your reactors are more than 30 years of operation. Yes, and they have done that, and we are doing that today in our fleet.
Thank you. So I think you've basically answered my next question, which was how to improve operational excellence. I think basically you've got a lot of points there. So I can move on now and ask the next question to Wang Yongge. Again, for you in China, what are the challenges and key success factors for competitive nuclear energy for you?
这个我想，这个核电呢，首先安全当然是最重要，但是在经济的竞争力方面呢，我想价格可能是我们更要关注的问题。简单来说呢，有3方面的关键因素。首先呢，要便于建造，成本和工期呢都要限制在可控的范围内。当前呢，很多项目的失败呢，都是因为建造中工程拖期，造成成本的大量增加。其次呢，要有一个可接受的价格。现在各国越来越多的这个严格的安全标准和管理要求呢，使这个设备制造、机组的建造和运行呢，成本都在不断的增加。第三呢，我们要便于运行和维护，要降低运行中的成本，比如说提高这个燃料的燃耗、更高的可利用率和减少放射性废物等等。
First, when we are talking about nuclear power, safety should always be given top priority. But in order to increase the competitiveness of nuclear power, we should also consider the price of it. So, in simple terms, there are 3 key factors. First, the construction should be smooth, and the cost and construction period should be properly controlled. Nuclear power projects in the world failed in the end, mostly because construction delay and cost rise. Second, the total cost should be acceptable. Many countries are taking more stringent safety standards and management requirements, which unconsciously increase the cost of equipment manufacturing, reactor construction, and NPP operation. Thirdly, the maintenance should be convenient. While the safety operation of nuclear power plants must be guaranteed, the operational cost should be reduced with higher burnout and utilization rate, as well as less waste.
Thank you. So the next part of the question being, what programs have you implemented to improve operational excellence and performance, and how is Framatome helping you?
中核集团呢，首先自主研发了3代的核电技术，华龙1号拥有更好的安全性和经济性，比如说177的堆芯、能动和非能动的安全系统，1200兆瓦的电功率，60年的设计寿命，18到24个月的换料周期等。近年来，通过一系列的新技术提升，也大大的提高了我们的建造水平，提高了项目管理的能力。在运营方面，始终保持着高水平的安全运行。中国核电运行从来没有发生过2级以上的运行事件或者事故。2017年呢，多台机组在WNE的排名呢都是综合排名是第1名。Framatome是中核集团最重要的全球合作伙伴之一，在设备、燃料和技术服务方面，和中核集团都有非常密切的合作，给我们很大的支持。
CNNC has independently developed the third-generation nuclear technology, HPR-1000, which has better safety features and economics. It is featured by 177 reactor core, active plus passive safety systems, 1,200 megawatts capacity, 60 years of designed life cycle, and a reloading period of 18 to 24 months. In recent years, with the technology development, CNNC has improved its construction and management capacity. All its power plants are in safe and good operation, with no accidents above grade 2 ever happened. Several units of CNNC ranked first in the WNE Composite Index. Framatome is one of the most important global partners of CNNC and has close cooperation with us in equipment, fuel, and technical services.
Thank you very much, Mr. Yong. So let's now move on to back to you, Mike. I think this is an interesting point. We're talking about performance, we're talking about competitiveness. Exelon has a very long history of innovation, which is key to improving competitiveness, and is performance-driven, I think, is the term that you like to use. So how does innovation influence overall performance? How can it, in your view?
Well, I think it starts with culture. You know, first of all, the organization, and the immortal words of Disney, when you wish upon a star, it doesn't matter who you are. We believe that, and we try to put that in the DNA, in the fabric of the organization. We don't believe the best ideas are born in the boardroom. We believe they're born on the shop floor. And it starts with our CEO, my boss, every year, just to put his beliefs into action. We hold an innovation symposium in some of the largest football stadiums in the United States. We fill up Soldier Field one year, Raven Stadium in Baltimore 3 years ago, the National Convocation Center in Washington, D.C. Last year, it'll be there again this year, where we have thousands of employees, thousands of our our vendors, different manufacturers that come to display their ideas just to foster new ideas within the organization. We stole a little trick from General Electric, a process that they called their Entrepreneurial Growth Board. In addition to that, he chairs that as the CEO, and employees are welcome to bring in ideas on new ventures. And what's grown out of that is different industries, like we're part owner of a battery company, we're part owner of a drone company, inspection company, we're part owner of an electric bus company out in California, and I can go on and on. We've got close to $100 million that are invested just in growth opportunities that are supportive or tangential to our core business, which is one of the principles that we always try to do. Innovation at Exelon really did start about 20 years ago, where we had this initiative to do refueling outages better than anyone else. We were pretty competitive about it. We wanted to do safe, short, efficient refueling outages. Running the largest merchant fleet, you have to. You know, you have to be the best at that. And we got pretty good over the years. As a matter of fact, we've operated greater than 93% capacity factor for the last 18 years. Last year, 94%, and we're on track for greater than 94% this year. It takes great ideas not only from our employees, but also for our vendors to do things like the Scorpion platform we use in our refueling outages, where we can do in-vessel inspections in parallel with moving fuel. which immediately takes about 2 weeks off of your base core outage. It's ideas like that. Now we've moved into trying to leverage technology. So synergizing our engineering force into one corporate location, doing remote monitoring using a common platform like Predix, for example, at our sites. So it's in the fabric at Exelon, and we can't do it alone. It takes partnership with companies like Framatome to work with us, to look for new ideas, to figure out how to do things more reliable, safer, and more efficient.
Mike, thank you very much for that. Back to you, Dominique. As you said, you've got the largest, you're very well positioned because you do have the largest fleet of nuclear power plants in the world. How, how does EDF position itself given that?
It depends on which topic, but just to give you and to go back on your first part and the question you have raised to Mark, I think, you know, the three pillars are quite the same. It's men, machines, and processes. Men, you have really to operate very well a power plant, you have to focus on men and women, but men generally speaking. What I mean by men, it means culture, nuclear safety culture, but it's also training. You need training, you need trained people. If you don't invest in training, you will not get results. It's basic things, but you have to do systematic training of your future operator, maintenance guys, and so on, and to be also very concerned by the training of your contractors that you use. So always to be really focused on men, culture, nuclear safety culture first, and performance-driven orientation. Second point is about machines. I am speaking about of the large refurbishment we have undertaken in 2014 in our fleet. If you don't have good machines, you will not be able to operate very well, even if you have good men. So you have also to invest in your machines. And moreover, it's linked, because if people see that you are investing in your machine, that you are taking care of the machines you are operating, they will be much more mobilized with you, and that's very important. And third point is processes. You have also to work through processes, which are usual processes about nuclear safety, about operation, outages, work performance. Quite all that is described now in 1.0 requirements. We know that quite well everywhere for all the fleets in the world. In the meantime, probably the most difficult thing and what we have innovated on in the last years was how to make the people of engineering working quite well with the people of operation, because it's two worlds usually. And you can easily be in the position of, you have people thinking of the good modification and the good things to be done. Then you say, okay, it has to be done. And then after that, operation people have to handle that, and they have difficulties to handle that. And how to have engineering people thinking not only of what is the best thing, but thinking in the way how the work I am imagining could be really implemented and operating in the future. This really needs a change of mind in engineering, and it's not so obvious to do that because we are not used to do that before. So I really focus on these 3 points, and thanks to these 3 points, when you have a look on the, I will say, on the performances of our fleet on the last 15 years, 10 to 15 years, what we see? We see that we have been able to decrease by 2 the number of scrams, for example, the number of reactor shutdowns. So it's very important. Second point, we have been able to improve industrial safety, to decrease also the number of injuries on our fleet. And third point, we have decreased a lot also our unavailability factor. It means the number of time when the reactors has been unavailable. We have decreased by 2 the unavailability factor of our fleet. In the meantime, it's true that we've extended the period of outages because as we have a lot of work to do, of course, we need time to do this work. And frankly speaking, for me, the most important is confidence, is to say, okay, when we will do this outage, it will take us 30, 40, 50 days, it doesn't matter. The most important, if we say 30 days, it should be 30 days. If we say 40 days, it should be 40 days. That's the most important for us.
I've got you. I understand, absolutely. Now, just a reminder, because we're not far off passing over to you. So please, if you have any questions, do pose your questions via the app. But before we get to that, perhaps one more question to you, Mr. Yonggi. As everybody knows here, China has an ambitious new build program, and it will start up the first EPR in the world, which is exciting news. What is CNNC doing to successfully complete its projects? How are you managing that and to have the capacity to supply competitive energy?
Thank you. 中国目前呢有38台的在运机组，18台的在建机组，总装机容量呢是58.2吉瓦，预计到2020年呢总装机容量达到88吉瓦，到2030年将达到120吉瓦。中核集团呢承担了中国大陆所有56台核电的和海外6台核电机组的建设任务，在30多年不间断的核电研发、设计、建造、运维，积累了丰富的经验，保证了核电项目在建设中进度、成本和质量都受控，并且培养了一支优秀的人才队伍。中核集团在项目管理中运用比较先进的项目管理的信息平台、Top 10的风险管理工具等，不断的改善施工工艺，比如说大体积混凝土、模块化施工、三维建模施工、设备预引入等方法。中国核电建设从来没有发生过比较严重的脱期的情况。当前正在建设的华龙1号在福清5、6号上创造了3代首堆没有发生脱期的记录。
China now has 38 nuclear power plant units in operation and 18 units under construction. The total installed capacity is 58.2 gigawatts at present, and it is estimated to increase to 88 gigawatts by 2020 and 120 gigawatts by 2030. CNNC undertakes the construction of all 56 NPP units at home and 6 units abroad. With 30 years of constant efforts in nuclear power research and development, design, construction, operation, and maintenance, CNNC has accumulated abundant experience. It takes good control of project cost, progress, and quality, and has trained an excellent team of talent. CNNC adopts many innovative tools in project management, including Project Information Management System, Top 10 risk management software, and etc. Meanwhile, it constantly improves and introduces construction technologies, such as mass concrete casting, modular construction, 3D modeling construction, and pre-installation method. China has never seen any serious delay in its NPP construction, and Fuqing NPP Unit 5 and 6 are making a new record in non-delay construction as a third-generation nuclear power units.
Thank you very much, Mr. Yonggi. So I think we can now open this up to questions. We've had a great overview of what's been done to improve performance and competitiveness. So I'm hoping that we've got some questions here. Okay, we do. What lessons have been learned out of the NEI initiative in the US? Delivering the nuclear promise, which is your catchphrase, is that right? Is that for New York? Have I got that right?
Delivering the nuclear promise?
Yeah.
Yeah, Maria mentioned yesterday that this was an initiative that the industry put together and realization that if we don't become cost competitive, in particular with natural gas, which I mentioned earlier, and renewables, we won't exist. And the technology is so great. I'll mention, we just installed a couple CCGTs down in Texas, one outside of Houston, one right side of Dallas, Fort Worth. And the technology is such, without naming any vendor names, these particular CCGTs we installed for less than 1/10 of the cost that it's going to cost my colleagues at Southern to install the Vogtle plant in Georgia. They're 1,200 megawatts each. They have ramp rates of 100 megawatts a minute. They have a heat rate of 6,300, and at $2.50 gas, you do the math, they're always going to be dispatched. They can idle, which has normally been the Achilles heel for CCGTs. They can't get below 60% because they can't meet their emission requirements, their NPDES requirements. These particular machines can ramp down to 20% and sit there and idle. They can chase the wind, as I mentioned, for you operators in the room. 100 megawatts a minute is fast. That is a fast rate of increase in power. And they're air-cooled, so they use about 1/10 of the normal water supply. Texas is a little droughty. So that's the competition, hence just to give you an idea of what we're up against. A lot of very, very interesting initiatives have come forward. One of them was declassification of safety-related components. On the old way we licensed these plants, all systems, if they're safety-related, every component in that system was classified as safety-related. We can go through now and using a common process, and there are not all the components need to be safety-related in that particular system. That saves lots of time in preventative maintenance templates, it's man-hours out of refueling outages, and it's cost for material when you buy those parts. We have very large construction forces at our facilities, primarily after 9/11. Some of the most secured facilities in the world, using common approaches and sharing common approaches and timelines through delivering the nuclear promise. We're able to go back now and reduce, without losing any capabilities, some of those strategies at those plants. So a lot of money there.
Thank you very much, Mike. Okay, let's see if we have another question. What new development in fuel technologies can enhance fuel performance? I don't know who wants to answer that one.
I will try to do some ideas about that. First, there are short-term aspects, middle-term aspect, and long-term aspect. On short-term aspect, you have already, usually speaking, a good fuel for an operator is a fuel we don't speak about. To be clear, it's a fuel we have no problem with it, and we don't hear anything about it. To be clear, for an operator, that's the best fuel. And from time to time, it's not the case, and we have to fix some issue. We had to fix some issues on some fuel performance in the past. Now they are in the way to be fixed. One of the most is the robustness of the fuel assembly, to be as rigid as possible and not to be too much flexible in the core. But this is an issue that could be fixed today. And as far as I know, in France, but I think also in US today, the number, for example, of fuel failures, small fuel leaks, are decreasing. So it's a good signal also for the performance of the fuel.
And most of those are self-inflicted. I'll be honest, Dominic. In ours, anytime we get a fuel leak, after all the advancements that have been made in fuel technology, it's FME is what we find more than often. It's problems that we had or a gasket material that we weren't aware of that got into the stream and caused wear and fretting on the bundle itself.
That's true. And on the long-term basis, what we are really interested in the development of, for the time being, it's R&D, but I do hope it will not be R&D in some years, is what we call accident-tolerant fuel, which is very interesting technology that if it could develop and go to the end, it will be very interesting for a nuclear safety point of view.
What's it called?
Accident-tolerant fuel. You know that you have seen that in Fukushima and Chernobyl, in 3 Mile Island, when you have some fuel, when you have some leakage and you have no more water in a reactor, you could have beginning of the core melting after, I will say, 4 to 8 years. 8 hours, sorry, 4 to 8 hours. But with accident-tolerant fuel, the type of cladding and the type of mixed fuel you could have could tolerate a lack of water for more time, maybe 24 hours, maybe 48 hours in the future. It means in this type of kind of situation, you will be able to bring back water and to have no core melting in the future if we are able to develop this kind of fuel. It's very interesting for a nuclear safety point of view.
And are we, how far off doing that, would you say? I mean, that's a...
I think Bernard could answer better.
I think I shipped to you this week some of them. So yes, they're in the nuclear reactors in France, in the US, and it's a it's life. It's happening now. And beyond this, we have also new generation. And for example, we have a cooperation with Lightbridge in the US to prepare already the next generation of fuel. Finally, I would mention one aspect. Mike explained how sensitive he is on the refueling outage. And we also have developments on fuel that allow a longer life. So in absolute, to reduce the number of refueling outages.
Thank you. Thank you very much for that. On to the next question. Is there a way towards even more competitive nuclear with new disruptive conception reactor designs, SMR, for example? Who would like to speak about that? Mr. Yonggi?
这个新的小型的反应堆，我觉得还只是在新的小型的反应堆呢，现在还不能说是一种对核电的一种颠覆性的概念，只是在减少了它的规模，增加了它的环境的适应能力。但在中国呢，正在研究开发的呢有高温气冷堆和这个磁式这个供热堆，这些呢将在特殊的应用方面，包括在跟过去传统的压水堆方面呢，都会有所不同。这些呢，我觉得这些的概念呢，可能更具有创新性。
First, I have to be honest that I don't think the SMR is a very disruptive concept of new design. It is simply reducing the scale of the nuclear power plants while increasing its adaptability. In China, there are some relatively disruptive new designs, such as the high-temperature gas-cooled reactor and the pool-type heating reactor. They can be used in different ways, and their usage are quite different from the traditional pressurized water reactor. I think they are more likely to be disruptive concept.
Thank you. Anyone else want to add to that?
There's a lot of support in the environmental community in the United States, also in legislation on the Gen 4 reactors and also SMRs. And as I look at the demographics of the current fleet that we have going on, I really see it as a bridge to the Gen 4 reactors and the SMRs. The SMRs, now we need a clear energy policy like I spoke earlier, because we need nuclear to be valued in the marketplace in the United States for all the societal benefits that it brings. We see it as a national security imperative, obviously carbon abatement, obviously clean air. So there's many things that it brings. But SMRs, I think, have a specific advantage because it's much less of a cash outlay for any of the utilities to tackle, obviously, just based on its scope and size. Most passive in design, which is another great advantage. The Gen 4 reactors, there's a lot of excitement around those, both for their passive designs and then also for their reliability.
Just a few words. Of course, SMR is interesting, but I think we have not to oppose SMR and new technology and new reactors with the reactors we are today putting on connecting to the grid, like we are doing you will do closely in US, we will do in France, our colleagues in China are doing, our Russian colleagues are doing too. We have not to oppose them. I think what is very important is that this kind of reactors, this kind of ideas, is really bringing new ideas and maybe to attach new talents. It's very effective because it means that nuclear could be something else than what we have seen for the time being. And I think for a new generation, it's very important to imagine that nuclear could be something different in the future years compared to what we are operating today. In EDF, we are mainly focusing today on what we call technological bricks, because when you have a look on all these technologies, you have some key points which are quite the same to be fixed, whatever the technology. For example, I've spoken just before about accident-tolerant fuel. This is a technological brick. If you really fix it, it could be used in every kind of technology of reactors.
Thank you very much for that question. Right, we've got the next one already. Then then I'll ask Bernard to conclude. So, do we need energy market reform to make nuclear competitive in addition to technical improvements? I think you touched on that, didn't you, Mike? Really. Do you want to add any more?
You know, without repeating myself, in the United States, and I'll speak specifically, if you are a merchant power plant in the United States, for us to be able to build and compete with cheap natural gas and subsidized renewables, we need energy market reform. We need nuclear valued for the societal benefits that it brings. So, yes.
You need a kind of level playing field compared to other renewables who are heavily subsidized, has to be said. Yeah.
Yes, or it's very difficult. You know, if you take, for example, our company, largest merchant generator in the United States, market cap is about $40 billion. A new twin reactor, say it's $20 billion. You got a $40 billion company building a $20 billion nuclear plant. That is a tough sell in the boardroom. You know, it just is. It's, unless you have the market that supports it.
Absolutely. I don't know if we've got time for one more question. Nobody's given me the answer, so I'm going to allow myself one last question, if we have one. Do we have another one? Do we have another question? I'm waiting to see. It doesn't look like we do. If we don't, in that case, I shall pass over to Bernard to conclude. It's been my pleasure to be your moderator. And Bernard, a few words of conclusion.
Yes, thank you very much. So, at Framatome, our commitment is to be a reliable and competitive partner for our nuclear operator customers, for Mike, for Dominique, for Wang Yongge. And I thank you very much for your presence here. So this goes for us through safety culture, this has been mentioned. This goes through technologies and also processes, the way we work, the way we deploy them. Ultimately, it's a human challenge, and we see knowledge management as key. And at Framatome, we want to remain an attractive company, an international company, and that's our vision, to be high-performing people and technologies for safe and competitive nuclear plants worldwide. Thank you to all of you, and I wish you a very good WNE.
Thank you very much to our panel. Thank you for attending. Wish you all the best.